Okay, so first of all, thank you so much for the opportunity to be here today and to tell you a little bit about the project that we undertook over the last year. And thank you to the many of you in this room and those of you who aren't here as well who participated in the interviews that we did to try and learn more about the projects that were undertaken as part of this network. Because quite literally, this project wouldn't have been possible without the support of the many of you who got involved. And I'd also like to start just by saying that I think this network is really exciting and really important. And I think that the starting talk by Tim and by Maya speak to the many challenges that we face, not just in our food systems, but also if you think about the objectives of this network, it's also to tackle climate change and think about how we can repair our natural environment. And the more that we can integrate these big, difficult, global, complex problems to avoid the unforeseen consequences when we think about only one part of a system and not the implications on others, we really have to start thinking about these issues together in a concerted way. I think what's also really exciting about this network is the interdisciplinarity in bringing together the STFC capabilities with food systems and other challenges. I'm a big fan of interdisciplinarity myself. I think it's got a lot to offer, but increasingly if you look at the research on innovation and creativity, what people are achieving comes from looking at domains that are not within their comfort zone, by looking at what's happening in other fields. And I think this is a microcosm of that potential, and I'm really excited by what it has to offer. And that was, in effect, the starting point for this project, with the idea that, well, okay, so new and emerging technologies are not the only solution, but they're one part of the puzzle, and they probably have the great potential to not only address issues within our agri-food system, but also to reduce greenhouse gas emissions and address the big issue of climate change. But what does this potential look like? In what fields is it most likely to be located? And what are the enabling or constraining factors? These are really big questions, they're high-level questions, and we had a little bit of money to think about these issues. And so what we thought would be interesting is to take this network and the projects that have been undertaken, primarily in 2018, but a few in 2019, and explore the potential of these projects to do just that. What are they trying to do to address food systems issues? And at the same time, what could they do to address climate change? So we focused on these seed-funded projects. We looked at 18 projects. There were, I believe, 20 funded in 2018 and about the same number again in 2019. Most of the projects we looked at were in 2018 because they had gone the furthest in terms of seeing through the potential of the seed funding. And we undertook interviews with 19 individuals. Most of these were PIs or co-investigators of the project. We talked to at least one PI or co-I from each of these 18 projects. Some of these people were involved in projects from 2018 and 2019, and we tried to cover that off in one go. We also talked to champions in the thematic areas and facilities experts. Many of these were also PIs and co-Is, and 2 of the network co-investigators. And we selected all of the projects on the basis that we thought, as a research team, that they had the potential to do this dual function of addressing climate change and food systems challenges at the same time. So that was already in the back of our minds when we chose the subset of projects that we focused on. So you've seen this diagram already quite a few times, but I thought it would be a nice prompt for describing the projects that we looked at. So across the top, of course, you've got the food systems components from production to consumption, and most of the projects, when we selected our sample, were focused on production, so that was 11 of the 18 projects, and a slightly smaller number somewhere along the supply chain, there were 8 of those, and 1 on the consumer end of the spectrum. And if you look across STFC capabilities, you've got the data science, technology, and the facilities. And most of the projects, as it turned out, focused on sensing and imaging capabilities. Again, 11 of the projects. And data science followed after that with, I think, 6 projects. But sometimes these technologies, facilities, and data science were used together, and some projects incorporated multiple different capabilities in one project. So turning to the potential for climate change, addressing climate change, we found that 15 of the 18 projects had an indirect potential rather than a direct potential. Of course, they were all chosen on the basis of that climate change addressing potential. And to give you two examples of these projects, one of them was looking at ammonia emissions, and it applied sensing technologies that are used in astronomy to enable measurement, continuous measurement most importantly, of ammonia emissions from agriculture. And so while ammonia is not a greenhouse gas itself, it's got an important role to play in nitrogen management. So there's potential there for tackling climate change. Another project in the supply chain was trying to use STFC sensing technologies designed for planetary exploration to detect quality changes in fresh produce, with the implication that we might waste less food or transport less spoiled food by understanding these things in a better way. A smaller number of the projects had the direct potential to address greenhouse gas reductions, so 3 of these projects, and I'll mention 2 of them here and the third one in a moment. The first of them focused on the potential for vertical farming and tried to understand, given all the different data that are needed to create a good artificial climate system, how could you scale that up and use the data science capabilities to, in effect, reduce the greenhouse gas emissions per kilo of food that's produced through vertical farming? A second project focused on the consumer end of the spectrum and used a citizen science platform to try and, that was originally designed to identify galaxies, but in this case they used it to talk to people about and understand consumer perceptions of their calories and carbon emissions associated with their own food intake against what is actually the case. And to try and use that information to identify better policies for helping people make better food choices, maybe eat a little bit less meat, a little bit more plants. So if we turn to the technology side of things, the technologies that were most commonly applied within the projects that we looked at were, I mentioned earlier, sensing and imaging, large-scale data science, and data sharing. And I'll just mention 3 of the projects here, or 4 of the projects, because 2 of them are together. One is the role of biochar in agricultural production. It's an input which can improve soil health, but also can sequester carbon. And it used STFC capabilities in imaging, detailed imaging, to understand the structure and absorption capacity of biochar and to be able to leverage it in different kinds of environments that has previously not been able to be used in. The second set of projects was trying to look at using STFC data science capabilities to model how climate change will affect different crop production, and maybe to select better, more resilient crops as a result, with indirect opportunity there to mitigate the impacts of climate change. And the final project set out a concept for how the combination of data sharing, and analysis and distributed ledger technologies can kind of optimize the measurements across the food supply chain. So I've talked a little bit about the projects and the potential, whether they be indirect or direct, for climate change mitigation. We also asked the people that we interviewed what they thought were some of the other kind of critical components of bringing together these ideas in new ways. And I think these are some very obvious observations, but I think they really merit mentioning. So the first of them is funding. So these are obviously very small pots of money to bring together new ideas. But funding was seen as a key constraint in getting to the next stage. So there's lots of big pots of funding out there. They're very competitive. And if you want to actually create a prototype from some of this research, or kind of bring the idea to a stage where you might get commercial investment, actually you need an interim or a stopgap funding measure to kind of get you to that stage, and that was seen to be a challenge by many of the interviewees that we talked to. I think also really interesting, and I think it speaks to the people in the room today, is the importance of connections, and not just connections, but physical connections, because when you're trying to bring together people from different disciplines to talk about complex problems, people who might not necessarily ever meet or have the opportunity to get together, it's actually networks like this that really facilitate that kind of interaction, and everyone we spoke to said that that was a really critical component of success. So this is obviously a very exploratory piece of research, just trying to understand a little bit about what the potential is for trying to bring these fields together. But I think there's a real opportunity here to identify technology trends more generally. And I think if we could expand the project to develop a framework which tries to look at the issues across the food system and climate change, and to pair that with a horizon scanning exercise to look at the potential for new technologies, we might be able to identify where there is a lot more potential. And I think the implications for this are great. I mean, if you could identify what technologies might be optimized in these domains, you might inform emission scenarios. You might be able to guide research and investment decisions. And you can also support decision-making to create a more enabling environment for this kind of work. And I hope that this project provides at least some inspiration and maybe even a prompt for some future research in this area. Thank you.